Good day everyone. Once you have decided the ESC and the motors, it is necessary to test your entire setup before flying the drone on the mission. The current lecture talks about how do you test your setup before deploying them on the drone. Let's look at them in detail in our upcoming slides. The first test is you test the motor for short circuits. If you use brushless motors in your industry, you want to make sure they are in perfect working order at all times. Although it's a good idea to schedule regular maintenance for all your electronics, if you can test your brushless motors yourself, you may be able to save your business some service costs. The way a brushless motor works is by using electromagnets rather than brushes to spin the motor. The magnets are attached to the motor's bell and push and pull the motor as necessary. Electromagnets can also be used to generate power. When you spin a motor by hand, it generates power. Many modern generators use the same process to create power. If any of the two wires are shorted together, you will experience resistance if you try to spin the motor by hand. If you separate all the wires, the motor should have no problem spinning when hand propelled. If you have separated all the wires, and the motor still resists spinning, you can assume you have an internal short circuit. If your motor is spinning, but it had recently overheated or sustained damage, you may want to dry test it to see if there are any problems with it. Here are the steps you can take to dry test your brushless motors. Step 1. Disconnect the motor from the electronic speed controller and wind it up with a variable speed battery operated drill, holding the stationary part and the 3 lead wires isolated. Run it at full speed for a couple of minutes. If the motor makes a strange noise or something inside the motor something inside the motor gets hot, you have a shorted winding or a loose magnet is hitting the stator within the motor. Step 2. Label the 3 motor wires, making sure to continue to isolate them from one another as 1, 2, and 3. Now connect your voltmeter to an AC range and connect 2 of the wires to terminals 1 and 2. Wind the drill at full speed again and note the AC voltage. Repeat this process with terminals 2 and 3 and 1 and 3. If all 3 readings are not about the same, you have a problem with your motor wires. Step 3. Check for short circuits between the stator and the windings. Look for any connection between the windings and the motor stator laminations. You will need to find a bare metal on the stator for one connection to the meter and on the meter windings for the other. If you cannot find one, create one by poking through the coating of the steel laminations. If the meter doesn't read an open circuit, your motor is probably short. Step 4. If your motor passes all of these tests, it should be good to go. However, before putting back into operation, you may want to check the no-load current of the motor and compare it with the specs provided by the manufacturer. This will allow you to identify a shortened turn in the motor or a winding that has shorted out. If you have a shorted turn, you cannot use the motor. It will generate very high temperatures, causing the motor to fail and possibly do damage to your ESC. If your brushless motor passes all the tests and seems to be functional properly, you can put it back into operation, although you should still keep an eye on it and inspect it as a part of your regularly scheduled maintenance. If the brushless motor fails any of the tests, you will probably have to get it repaired or replaced. Once the ESC and motor are ready, it's time to put them on the motor. Thank you.